Hey guys, welcome back today to DLH Performance. Lately I've been pretty busy, so I haven't been able to put out any videos, but I got a little bit of spare time now, so I thought I'd pull out one of my projects. I got lots of projects on the go, and this is one of them. So this is an old engine that I had. I built. It was one of my first hybrids. And I just have a bunch of random parts. The old head off of it. What else do I got in here? This was one of my first spacers I ever made. A long time ago, probably about three and a half years ago, before anybody was building these hybrids. Well, some guys built hybrids previously before I did, but that's one of the first spacers that I did about 3.5 years ago. A lot before a lot of guys started building any of these Minarellis. So this one's a jog setup for this one. Like I said, I got a few random parts here. This was the original cylinder head that it was on it. Just a cast iron. But these ones here happen to be 50 millimeters. So they're a little bit different size, the jogs, than the normal Minarelli, which you can just drill out and put onto a normal case. So you have to do a little bit more modifications to your case. So what else do I got here? An old cover. Old cover. This is all just kind of like just put into this. This is one of the old covers that was on it. Not sure what parts I'm going to use out of this. An old G2 reed block. Here's the engine itself. Piston that came with that. Here's the old engine case itself, case reed, with one of my original SAF super clutches on it. It's got the 540 pound springs. It's a 40 millimeter stroke balance crank. I drilled these out. I plugged them and then re-drilled for my spacing to fit the larger cylinder pattern for 50 millimeters by 50 millimeters. There's not a lot of room on these G2, or not G2, but GT90 cases. And these are getting rare now, these cases. And we're going to see what we can build out of that. So, some other covers here I might use. Might repaint them, clean them all up. Also, I got in here another cover. And then what got me wanting to do this project was Don Butler. Don Butler sent me out this stage 6 70cc street race cylinder, and I thought, hey, he said that he couldn't use it, so I said, well, send it up to me, maybe I can do something with it. So since I have this case here and it needs to be redone anyways, I thought this would be a great opportunity to build this cylinder. So I started on it and I made a new spacer plate for it. Similar, but a little bit different angles on here. Because I have these laser cut one size to fit the regular Minarelli, I had to oblong these holes a little bit. That should be fine to make up for the larger spacing. And then this cylinder. So on this cylinder here, it's almost similar to the same as this one here. This one is ported out a lot and has a little bit different port timing. And really interesting to see what it's going to do. So I started this already, and I brought down the side skirting and blended it in here and here. Did a little bit of port work here, but other than that, this cylinder is pretty clean. It's got a really nice big exhaust, really nice transfers. This one has 1, 2, 3, 4, 5, 6, 7 ports on it, and be interesting to see how it runs. And we're going to put a little bit of a hone on this as well. What else do I got in here? Just a new piston. See what the difference is between these two. They're almost the same. Nice low window piston. Stage 6, 4.6.95, 47 millimeter piston. Same as this. Okay, well, I just got a few other gaskets that came with the engine. That might use new pin, new rings. So anyways, I'm going to get started on this project and see what we can build. So we're just going to start to clean up this engine case, so that's what we'll start with first. And I'm going to basically, just pull it all apart. It does have balanced crank in it, like I said, for the 47 millimeter piston. We're just going to go ahead and pull it apart, clean all the gaskets because it's been sitting for a while. And clean out the inside, and then I'm also going to put on Powerstorm ignition system onto this. We're going to put one of my new SAF force clutches on here with the skull pattern on it, the special edition skull pattern. Should look pretty cool. So anyways, might as well get started pulling it apart. Alright, I got the case all apart now. It's just a matter of cleaning up. I might do a little bit more port work, but it's pretty smooth in there. Cases look pretty good. Here's the balance crank that was in it. I think that one was 6% over rotational mass, I believe. But I'll be checking that and truing it. We're going to get new pads in here. I'm still not sure if I should go with these CNC covers yet. It's a good possibility. I just want to look at my old style SAF super clutch. This one here, I did do a limited edition laser print with DLH his name on it. I did have a couple customers. I did have a couple SAF super clutches, the Gen 1s, go out when they were laser cut and the metal was bad, and I didn't know until I sent it out. But you can see on these, like, perfect wear. Like, there was no issue with these in the way they were making contact. And like I said, I only had a couple that went out, and any ones that I did send out that were warped slightly, I did replace. A couple guys wouldn't accept me replacing them, but it is what it is. So this is our new style SAF Force. This is, I think I'm going to throw this one on there. This is the limited edition with skulls. and it's CNC'd, so it's a perfect surface area, 100% balanced. Should work really well. So it's just a matter of cleaning up these parts now. And I just want to touch base with the GT90. There's a couple things with the GT90 I really don't like. It only had 6mm bolts instead of the 8mm. You'll find that on a lot of them. 6mm. They should be upgraded to a 8mm. I might re-drill them and then re-tap them while I have it apart. All the bearings and everything seem to be good in the engine. I'm just going to clean up the reed block and figure out what I'm going to do with what type of carburetor I'm going to run on it. So let's just look at some of these stator coils. So this is my new this is the GT90 stator coil that came out, and it's got a large wrap on it, and you would think that it would read really high electrical friction in ohms, but it all depends on how they wrap this, the type of wire they use. If they use a thicker wire, you get less electrical friction, measured in ohms. And this is a stock basic one, and you can see the wrap is much smaller. This is my new Powerstorm ignition system stator, and this one really has a really tight small wire weave, and I'll show you the difference. Like, it almost looks like the GT90 is larger, and we're gonna do a comparison here and see what kind of electrical friction that these all put out. So let's start with our regular stator. This is just off a regular engine, and we'll set our meter here, and we'll just take a measurement. And we'll just put it that way so we can see it. Okay, so I'm going to measure the blue wire, and we're going to measure the black wire. And that one's measuring 319. Oops, popped off there. 319, 320, and that's average. Anywhere from 3 to 320. That's on your basic stock stator. Okay, so now let's go to the GT90 with a huge wrap on it, and we'll see what we get with that. So, okay, so even though it's very big, even bigger than my Powerstorm ignition, we're only reading 336 ohms, and you would think it would be a lot higher, but it's not, and that has to do with the quality of wire, copper wire, the thickness that they use, and it must be quite a bit thicker in this one. So larger always doesn't mean better. All right, which you would have thought that was a high performance ignition that went with the GT90 case. All right, here's the Powerstorm ignition, and we're going to hook this up to there, and we're going to see what kind of electrical friction we can measure off this, and we're at 465. Now these ones go anywhere from, I see them like 460 to 480. This one happens to be 464 ohms, which is quite a bit, substantially quite a bit more than all the other ones. And these are one of the higher ones that you can get right now with the Powerstorm ignition system. All right, and those are on my website. I have them readily available for anybody who is interested in one. But we're going to be putting one of these onto this engine. All right. So now I want to show you a little thing about the magnets. Okay, we have two magnets here. Here's my Powerstorm magnet. It's all machined, perfectly round, balanced. And here's just a regular stock one. This one happened to come out of the GT90. It's not as not quite as nice as the Powerstorm magnet, but I mean, looking nice isn't always the most important thing. It's how powerful the magnet is. This one's quite strong, this magnet, and we're just going to do a little test comparison. So this is one way to test magnets and their strength. What you can do is you can take this and I'll use a weigh scale that I have here. Let's set this on. Okay, we're measuring it in grams, so it's not like to 0.0. See how many of those take. So that's it's where it's saying. Okay. Anyways, so let's take this magnet and we'll move it around in here. Maybe I grabbed the wrong screws here. Yeah, let's change to a better screw. Okay, that's better now. Okay, now I got the right screws. All right, so let's take this. We'll measure it out to see what we get. All right. We're measuring at 18.5. All right, so let's take all these and put them back. And we'll take the Powerstorm magnet. This magnet is really strong. Okay, that one's measuring at 29.4. So with that, just that simple test there shows you the strength of the magnet. Now this is just a simple test and easily available for anybody to do. There is meters, expensive meters that you can get to measure the strength of the magnet. I'm only showing this method because it's something that everybody can do. So if you want to see how strong your magnet is, there is other methods similar to this, where you can stack stuff on your magnet to see how much it holds. Or you can do like a grab test like this. And get you know, a good rough estimate on how strong your magnet is. But so there it is, Powerstorm magnet, high performance GT90 magnet. These are actually even better than the original ones that went with this one, and this thing is like crazy powerful. All right, so let's go ahead and clean up these cases and get the crank ready and get ready for assembling. I'll probably throw a paint job on here since it's going on to my Green Hornet bike. I might do like a green and black paint job on this engine, and as we assemble it. So this is the complete package here: magnet, stator, CDI that comes with the Powerstorm system. I just want to mention I'm selling these at a super low price. I'm not sure how long I'll have them for. I have quite a few of them in stock. I'm trying to get some more. They're a good setup, one of the top on the market that you can get today. 460, 480 ohms, super powerful magnet, and upgraded to high performance CDI. All right, now I've painted up a few parts now. Painted the engine case, well, cleaned it up, of course. Painted it green to match my bike. So that's almost ready to go. Start installing the crank and the clutch shaft. I took the crank out and checked its trueness and cleaned it all up and made sure it's working in good condition. I took the covers and cleaned them all up. I decided to go with these ones and did a little paint job on that, which I think they're gonna look great. And I painted the reed block. So I think it should look pretty sweet like that. And there's reed in here like that. It should look quite nice. And then we're going to install the new force clutch on there. So, and it should be like something like that with that on it. Should look pretty good. That's so what I'm doing right now is, and then of course we're going to add Powerstorm ignition here right away. So what I'm doing here right now is these just got a slight bit of glaze on them. They're worn down a little bit. They're not totally worn out, but I'm going to put in brand new ones. So I'm just going to go ahead and remove all of these. Just take them out of there. We're going to put new ones in. So what I usually like to do is I'll take the new ones and what I'll do is I'll file them down a little bit on each side to make sure that when they go in they snap in place. That one's not too bad, but I'll just remove a little bit of material here until they fit nicely. They're snug, but they're not so tight that it breaks the edges, you know, when you put them in, and making sure they're all sitting flat. Okay, the Powerstorm ignition is installed now. We're going to go ahead and I want to talk a little bit about seals. So I took this seal, this is the old seal, and I did the inspection on it. Made sure that the inside of the seal is in good shape and the outside, no nicks or any issues, and the spring is still inside the seal. So this is what I do. So I take just a little bit of lube, just make it go on a little easier. Just a tiny bit there. And I'll take some Loctite and I'll put it on There we go. Just put on the outside edge here. This is going to help keep it sealed and set in your case. So it's just a thin film you're putting on. This will also help with the installation. It'll go on really nice and easy. So I take it, put it in, and this can almost be just pushed down by hand now to set it. Making sure that it's nice and flat and even. There. And then I'll just clean up. Let's go ahead and clean up this excess in here. There. Inspect it, making sure that it's even all the way around, nice and flat, round. And that's the way it should be. If you install them like this, you shouldn't have any issues with them at all. So this is the stage 6 cylinder. Another point that I wanted to touch on. This is a pretty high quality cylinder, and it's got really high tolerances for its quality. So even with the piston and everything, compared to some of the other kits that are out there, even though this is still a cast iron cylinder and aluminum piston, you want your piston to be able to do this. You want it to be able to fall through with no restriction at all. If your cylinder doesn't do that with your piston, right, then what you need to do with these cast cylinders is use a ball hone. You coat the inside with oil and engine oil. You coat the balls with engine oil, and you run this up inside, in and out, all the way through, up and down, up and down. It'll cause really nice hash marks, cross cuts, and you'll hold out your cylinder. Now you only need to do this for about 40 seconds at a, I think it's 600 RPM, I believe it is, to get it to hone. It's not super high speed, but it's not really slow. And you just work it up and down. These ball hones, when you order them, these are really nice to have. When you order them, they come in different diameter sizes, obviously, for the different size pistons. This one's a 46.95, so a 47 millimeter piston. And this, I believe, is for a 48 millimeters. I think that's the only size you can get, but it works nice, even though that it's for the slightly larger cylinder. It works really good in a 47 millimeter bore. With these hones, they're nice to have on hand. For another reason, for setting up your engine and stuff too. Obviously, once you've honed it, you want to clean it very well afterwards, and then oil it again before you assemble anything, making sure that it gets out of the port areas and everything, all that fine dust that you've honed. What else I want to mention is, if you get dry seizures, mild ones, on your cylinder wall, what you can do is you can use this hone to take them out, and nothing that's really a deep scratch, but minor scratches and stuff, you can hone out of your cylinder and then just get a new piston, or finish off the sides with, say, like a 240. You know, say I would just replace the piston, but some guys might not have that option. So you can just, as long as this area is not damaged in your ring area, where it's caused any kind of damage in the ring area for the rings to be free, then you can put this on, like, say, like a 240 grid and buff out any of the scratches on it. And that would be a Scotch-Brite pad or something like that. And you could reuse it, but personally for me, it would be a new piston if I went and re-honed it and it honed the marks came out. And then send it. So that's a little tip right there. We got the cylinder head on now. I was just dry fitting everything. There's no gaskets in between here. And I got a copper gasket on the top that's 0.7 millimeters. And we're going to do a dry fit and check our squish. So I got a piece of solder here, and it is it's about 1.5 millimeters. So that's a good size to check your squish. And what I'm going to do is I'm going to raise the piston so it's just before it hits the top. And you don't want to have it too low because your transfers are here, and you don't want to stick your solder into the transfer and then cut it off. So I just put a little slight bend in it, and we'll insert it into the head all the way to the cylinder wall, and then we'll turn it over. So just put it in there like that. Just double check this to make sure it's not too high, too low. That's pretty good there. Okay, I'm touching my cylinder wall. I'll just take this and I'll push it over. Right. So we'll take the calipers and we'll measure this off. So I'm sitting at 0.7. So if you're racing this engine at 0.7, yeah, you can get away with it. That's pretty high compression. You'd probably be pretty good. But if you're going to use this engine for a long, for riding it long distances all the time, with the high compression, I would say your needle bearing or your crank bearing would wear fast. So I prefer to run them up about, closer to 1 millimeter. But since this is dry fit here, I mean, I could put a slight shim in there. I have some really thin shims to bring it up a little bit, or leave the transfers where they are. So anytime you shim it at the bottom, it raises your transfers up. And we're going to check that in a bit here. This is the first step, seeing where the squish is and getting the squish. So I'm going to put silicone in here and in here, and that's going to raise it 0.3 millimeters. So I should end up at about a 1 millimeter squish where I want it, because there's nothing in here right now. And I'll be happy with that. So we're going to go ahead and put the degree wheel on, and then I'll just give you a quick show of what the timing is of these stage 6 street performance 70cc Minarellis are at, just so you got an idea of what where it's at. And I'm not really liking this color scheme too much, and I think I might change it. It's not really doing it for me, so we're gonna work on that as well. I just want to mention, if you get one of these heads, the guy who builds them leaves this really sharp here. I don't know if he's fixed this problem or not, but this is like razor sharp, and I have cut myself on those, and so I would suggest, if you get one of these, to cut these down. There, just so they're dull. Okay, I got my degree wheel set up now. It's even on both sides, so I'm at 12. I rotate it all the way around using my mechanical stop, and I'm at 12. So as long as it's even on both sides, then we know we're good. And we're going to go ahead and remove the mechanical stop. That way, when we turn it to top dead center, it will be on top dead center. Okay, so that's now exactly top dead center. So I'm going to start from the bottom. Okay, I'm going to start off at bottom dead center here, and I'm going to rotate the cylinder up to there, and we're at about 60. We're at about 60. So on this cylinder, let me just double check it again. I'm getting between 60 and 61. Let's say it's more close to 60. So 60 and 60 is 120. So our transfers are at 120, which is pretty good. And let's roll it up a little higher. And what do we have here? We have 90. 90, 91. Right there. So I go 90. So the exhaust is at 180 degrees. So 120 and transfers, and 180 on the exhaust, which is pretty good numbers. We'll test the engine and see how well those numbers do. So when I say my transfers are at 120, the way we set up the engine though, with and it's going to come up just a tiny bit, but that's not going to change it too much. I kept the cylinder really low. The head that's going on there is modeled after a Piaggio. It's got a really deep high head in it, more so than the stock one. So to get the squish, so once I got the squish, that means if you look at the piston, it's sitting up quite high. That's because the piston is going more into the Piaggio head than the stock one. The stock one, it would have been down a couple of degrees, so like more like that. So keeping the cylinder low and using that head to get the squish I need is kind of what I wanted. I want the cylinder to drop, so it drops my exhaust just slightly. And I mean, you can run yours however you want, but this is the way I wanted to test this one. I wanted the cylinder to be as dropped as low as possible and get my squish band so that my exhaust isn't being driven up. So I believe the port timings on this would have been around 124 and would have been about 94, so, or 92, in and around there. Would have gave me like 184, 186 on the exhaust. But having it this way with the deeper head drops all my port timings down. So initially what that's going to do for my engine here is still give me high RPM, and what it's going to do is by lowering my ports, it's going to give me more bottom end, and that's what I want. I want a good strong engine that takes off quickly off the line, that you don't have to pedal up the speed, and a good all-around engine. That's what I'm looking for. Just want to talk about this as well. A lot of builders, what they'll do is they'll lower their port timings, and the way to do that is there's a couple ways to do it. I've done it because I have a spacer and I don't have to put in the gaskets, and it lowers the whole thing down. And that's what the cause is. Happens is now my pistons is sticking out slightly, but with this head here, because it's based off of Piaggio, it's got a deep inset in here, so the piston can actually go inside the head, unlike the stock one. That's why I chose this one to do this. And so in my case, I don't need to put in the gasket. So if you're building a China doll and you want to lower the port timings, because the port timings are really bad in a China doll. So say your transfers are at 130 and you want them down to more like to 126. What guys will do is they'll remove material from the bottom of the case. So they'll deck their case, removing a couple millimeters off here, which drops their cylinder down and gives it the same effect where the piston is sticking up slightly on the top. So what that does is it drops all your port timings. Then you can raise your exhaust and you can get it to a better port timing from the bad port timing cylinders. This one is not, but I still want the lower end on it. So on a China doll, decking, dropping the cylinder, but then what you need to do is you need to take this to a machine shop and have them either get a head like this or cut a deeper groove into this area here, unless you have a lathe, a jig that you can do it yourself. Spin it on the lathe and you remove the material that you removed off of here. So whatever you moved off of here, say 1 or 2 millimeters, you would then remove it off here. Then when you put it on, check your squish with your head gasket, then you should be able to get your squish back. So that's one way, guys will get better port timing by lowering the cylinders. In our case with the China dolls and stuff, I'll do a video on that later. There is another way too, is but it's the same as decking your case, but guys will remove material from the bottom of the cylinder, which is a little more difficult, but it can be done. Putting it on a lathe, spinning off a small amount here, and then the cylinder drops, piston sticks up, and they cut out the head deeper so that it sits on. I don't suggest putting up a big, huge, well, if you were to get one single gasket, say copper, that would make up the difference, the thickness. You could do that. Another way would be, like I said, to just machine this out and keep a normal head gasket. So those are a couple options of ways that a guy can go about changing the timing on one of these engines. All right, I was saying that I really don't like this color scheme. It's not really working for me, so we're going to change it a little bit. Okay, there you have it. 80cc stage 6 street racing cylinder on a GT90 case. A lot of these products you can get on my website. The SAF super clutches, ported cylinders, spacers, intake adapters, ignition systems, and lots of other products. The link will be in my description below the video. And what we're going to do next is put this on the bike and on my next video, and we'll take it for a test. Also got this KX Kawasaki 80cc pipe that we're going to put on here, and should sound really nice. Excited. So watch for my next video when we take this out and put it on the Green Hornet and take it out for a couple test runs. Thanks for watching. Like, subscribe, and share. Thanks a lot.